and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe. This really helps the channel to grow. Today I will discuss macromolecule, the topic of organic chemistry of O level 5070 and IGCSE. Macromolecule is long chain molecule with covalent bonds. Macromolecule can be classified into two types: polymer and giant macromolecule. Giant macromolecule of diamond, graphite and silica, while polymer is the organic macromolecule, which is long chain molecule. Long chain molecule. Polymer is long chain molecule with covalent bonds formed by reacting many same type of monomers. Poly mean many, mers mean molecules. Mono mean one, mers mean molecules. Mers mean molecules. So monomers, many monomers join to form polymer. Polymer, there are two types of polymer: natural and man-made. Natural, there are three types of natural polymers: protein, carbohydrates and fats, while man-made are synthetic, like polyethylene, PVC mean polyvinyl chloride, perspex, Teflon, nylon and terylene. Polymerization is the process in which polymers are formed. There are two types of polymerization: condensation polymerization and addition polymerization. Addition polymerization examples are polyethylene, PVC, Teflon, perspex, etc. While condensation, there are two types of condensation polymerization: man-made and natural. Natural, protein, carbohydrates, fats again, while man-made, nylon and terylene. Addition polymerization. First of all, I will discuss addition polymerization. It is the chemical property of alkene. Empirical formula of monomer and polymer is same. Molecular formula of monomer and polymer are different. These are the features of addition polymers, which are very important to learn from the examination point of view. A relative molecular mass of monomer and polymer are same. What is addition polymerization? It is the process in which monomers of same type. This is very important point, that the monomers of same type are added to form polymer on heating. For example, if there are n number of ethene, we get polyethene, and for just break the double bond, and this is the continuous bond. By drawing the continuous bond with bracket, this is the polyethene and represent with n num. Similarly, there is, if we have three molecules of C2H3Cl, so this is monochloroethane, or it is also known as vinyl chloride. So when it is written 3, so just draw the 3 unit. 3 unit means 6 carbon atom along with the single bond. Double bond is going to break, while single bond, long chain of single bond, carbon to carbon single bond molecules. Like how to draw the polyethene? You know that over here hydrogen and chlorine, so just draw similarly, like first carbon is attached with hydrogen, second is chlorine, again carbon, hydrogen, and this is the second unit is going to start. The similar atoms are attached on the carbon atoms, while this is the second, this is the first unit, first molecule, this is the first molecule, this is the second unit, and this is the third unit. So in this way, because we have 3 molecules, so we only draw the 3 molecules after breaking the double bonds. This is known as monochloroethane, and this is known as polychloroethane. or it is known as vinyl chloride or polyvinyl chloride. So next example is tetrafluoroethene. Tetrafluoroethene mean tetra mean 4 carbon, and this is the molecule of monomer, and 2 unit when it is written over 2 along with the bracket, so draw the 2 unit, the same 2 units with single bonds. So this is the polymer, this is polyfluoroethene. So next process is condensation polymerization. Is the process, it is the process in which two different monomers react in the presence of concentrated sulfuric acid to form polymer and n number of 2 water molecules. It is reversible reaction, and you know that forward reaction is condensation. We have discussed earlier in esterification or ester formation. So this is the same process which you have done in ester. It is reversible reaction. Forward reaction is condensation, take place in the presence of concentrated sulfuric acid, while backward reaction is hydrolysis, takes place in the presence of sodium hydroxide. So there are two types of condensation polymers, man-made and natural polymer. So there are two examples of man-made in O-level syllabus, stearin and nylon. Nylon, we know that I have discussed earlier that there are two different molecules are used, or monomers are used in condensation polymer. So first in nylon, first is dicarboxylic acid. So there are two molecule of dicarboxylic acid along with this box. So this is one carboxylic acid, so that's why it is known as dicarboxylic acid. This box represents the long chain molecules of hydrocarbon or any alkene or alkane or any molecules present in between the this box, like hydrocarbon, you can say. Hydrocarbon second is diamine, and diamine is 2 amino group is attached with long chain molecule. So when these two different monomers react with each other, you know that this is the structure of dicarboxylic acid, this is the structure of diamine. You know that OH of this carboxylic acid react with H of this monomer, and OH of this carboxylic acid react with this hydrogen. So in the presence of concentrated sulfuric acid, forward reaction is condensation, while backward reaction is hydrolysis. Forward is condensation and backward is hydrolysis. So when two water molecules, in this way there is one water molecule and there is another water molecule. There are so total 2 water molecules are found when two monomers join together. So this is the structure. You know that when this OH to draw the continuous bond with square bracket and then write down the structure of this monomer like this. So OH is being removed from here, so it is directly attached with NH because hydrogen is also removed from this molecule. And you know that this is the complete two monomers when joined together, and this is one molecule, one polymer. When two monomers join together to get this structure, and draw the repeat unit like C double bond O. This is the long chain molecule, C double bond O, NH and NH. C double bond O and H, one unit is known as amine. When we talk about the all different NH C double bond O unit, this is the polyamide or polypeptide, we can say. One linkage is amide and the many linkages known as polyamide. So when we talk about this collectively, so this is known as polyamide. So this is the product of this, and this is nylon. This whole structure is known as nylon. This linkage is the uh, linkage term is used when second molecule is linked with this molecule. So the linkage which is formed in the polymer is known as linkage. Like this is another linkage, this is another linkage. So one linkage is amide while many linkages are polyamide. So along with n number of 2 water molecules. Product is nylon and water. Next example is terylene, and monomers are dicarboxylic acid. Dicarboxylic acid we have used in nylon as well. So dicarboxylic acid, 2 carboxylic group are attached with long chain molecule, and second is diol. Diol mean 2 alcohol group are being attached with this long chain molecule. Linkage is the linkage of this is ester. This is the linkage of the terylene when these two molecules. Product is terylene and n number of 2 water molecules. One linkage is ester and many linkages are polyester. So this is C double bond. It can be written as C double bond or CO2 like this. So this is the dicarboxylic acid when react with, this is the reaction diol, and H from alcohol and OH from dicarboxylic acid, and this OH from carboxylic acid and this H. So in this way 2 water molecules are formed. When water molecules are removed, the remaining molecules are linked with each other to form a polymer, and in this way many repeat units are many linkages are formed when we write down 2 repeat unit. So this is 1 unit till here, this is 1 unit, and from here this is another unit. So in this way 1 linkage is ester. This is the 1 linkage, and when we talk about many linkage, this is the many linkage 1 2 3. Many linkages, more than 2 linkages, are known as polyester, and n number of 2 water molecule along with this structure. This is polyester, this is known as polyester, as well as terylene along with 2 water molecules. The backward reaction is hydrolysis. We can say that the polyester is hydrolyzed to form dicarboxylic acid and diol. This is very important statement from the examination point of view, that it is always examiner asks you that ester is hydrolyzed to form which products. So this is very important to learn, that when hydrolyzed in the presence of water, it is again dicarboxylic acid and diol is formed. Uses of terylene and nylon. It is used in clothing, fishing net, polyesters and sleeping bags. Natural polymers. There are 3 types of natural polymers: protein, carbohydrates and fats. Proteins. In protein, monomers are amino acids. Polymers are protein plus n number of water molecule. Linkage is amide or peptide. Linkage of protein and nylon is same. So this is very important question from the examination point of view, that which have the same linkage. So nylon is the man-made polymer while protein is natural, but the linkage of, not molecule, linkage of protein and nylon is same. So this is the structure of amino acids, and one amino acid. So many amino acids join to form protein molecules, and you know that 20 different kinds of amino acid when joined together to form one protein molecule. So it is in the presence of HCl in condensation, HCl as well as HCl in hydrolysis. So this long chain is formed, and you know that in here on what n number of one water molecule are formed, and the same linkage which we have done in nylon. So this is the amide or peptide linkage. So this is the polymer is protein. So over here one H over here from OH, so water molecule and remaining right on the repeat unit of the C double bond ONH. This is repeat C double bond ONH and C double bond O box NH. So there are 1, 2, 3. 3 repeat units are written over here. So the linkage is one linkage is amide or peptide, or many linkages are known when we talk about more than 2. So this that linkage is known as polyamide or polypeptide. This is the structure of nylon. When we compare this structure, this is very important to identify the nylon polymer and protein polymer. And you know that C double bond O, and on the other side of this box NH is written, but in the case of nylon, C double bond O, and on the box where a long chain molecule is there, and after the box C double bond O. So C double bond O is repeatedly written after the box and before the box. Similarly, NH, and but here C double bond O, and after the box NH is written. So this is how to differentiate protein and nylon molecules. Carbohydrate monomers are glucose, polymers are carbohydrate. Condition is heat. Catalyst used HCl forward reaction as well as in backward reaction. Products are carbohydrate and n number of water molecule. Carbohydrate is hydrolyzed to form glucose, and glucose is condensed to form carbohydrate. Linkage is oxygen. Many linkage is polyoxygen. The reaction is over here. So this is glucose molecule, and you can write down OH and OH over here. So the hydrolyzing, when carbohydrate is hydrolyzed to form glucose, while glucose is condensed to form carbohydrate. So this is the structure. H from here, and H and OH from, you can remove OH or OH from any side or H from any side of this molecule. So this is the monomer, when many monomers join together to form carbohydrates. So this is the structure of, only O oxygen is written over here. So the common linkage is oxygen and n number of water molecules. The last polymer is fat. Monomer is 3 molecules of fatty acid, and second monomer is triglycerol. Condition is heat. Catalyst जो है वो that is hydrochloric acid and sodium hydroxide backward. Polymer is fat. Product is fat plus water. Linkage of fat is similar to the linkage of, this is very important point. So the fat linkage is similar to the Carrier linkage. Next reaction, this is the reaction, this is the fatty acid, and this is 3 molecules of triglycerol. So look at the 3 fatty acid when react with triglycerol. So H from triglycerol and OH from this, H from here, OH from here, and in this way 3 water molecules. And now it is formed water. When water molecules are removed, the structure is like this. So this is the fat molecule, and 3 water molecules are formed. Reactions are, you know that this is also written in your syllabus or in your exam. The long chain of this molecule is written like this. So in this way we can write down like this: O C double bond O, the same, but the linkage is same. Linkage of polymer ester and fat is same. So this is ester linkage, and this is the pterylene molecule. Fat is hydrolyzed to form glycerol and fatty acid, while fatty acid and glycerol is condensed to form fat. So advantages of man-made polymers, condensation and addition both. Light, cheaper, man-made are light, cheaper, insoluble in water and waterproof. Disadvantages are man-made polymers are non-biodegradable, like not decomposed by microorganisms into simpler substances. Hence, when they do not decompose, they cause pollution, and pollution landfill sites and on burning or incineration produces toxic fumes of HCl and hydrogen chloride. HCN is a hydrogen cyanide. Advantages of natural polymer. Natural polymers are biodegradable. Biodegradable mean decomposed into simpler substances by microorganisms, hence do not cause pollution. Disadvantage, they are soluble in water and heavy and expensive. So this is all about the macromolecule. Hope you will understand. So please